Hello there. Hello there. So we start a stream. Let me see. So let's talk a little bit about the project I'm working on right now. I'm working on MySQL binary protocol implementation pure PHP. In general, it's very interesting project because it involves parsing binary data, and parsing binary data is always a lot of fun. So I'm gonna write an implementation for parsing the binary protocol through a regular socket connection and to write back some data. Basically, this functionality will consist of some read buffer that just appends the data itself. It's a part of binary protocol implementation itself that is asynchronous, because in asynchronous programming, when you receive some data, you never receive complete packets. You always receive some small piece of the data that you have to try parse gradually as soon as you receive more and more of the data. So that's why we have some append method on our read buffer. And then we have a read fragment method. This is actually gonna be receiving a reader as an argument. Here we can actually see some example here in one of the tests. So let's say we have some binary data being supplied as an input. Then we try to read the fragment where we will receive a read buffer fragment reader itself as an argument here in a callback, and we will try to read one fixed integer, and then we assert that this fixed integer, this xf1, is actually 241. Let me actually also open a live chat as well to make sure that I actually can see what you might write in a YouTube chat window. Let's see. So I'm gonna YouTube open this up. So let me disable this audio. Okay, so now I have complete access to any kind of data you might write me. So let's have a real feedback. Okay. Let's see. Let's continue with the stream. Let's go to the MySQL manual page. We can see here that there is some information about the protocol frame of communication between server and client. There is, for now, I implemented integer types in my buffer reader. So I have implementation for fixed length integer. I have implementation for length encoded. Oh, actually, for length encoded integer, I don't have yet implementation. It's going to be part of the frame reader. Then we have fixed length integer, null terminated string, variable length string, length encoded string, rest of packet string. So all of those things needs to be implemented in order to be able to parse the frames itself, because if we go into MySQL packets, we can see that each packet starts with some declaration. So here, for instance, when we see integer and when we see 3 inside of it, it means that it's fixed integer of 3 bytes long. That indicates the length of the packet that we receive. And here we have also integer of length 1, that is a sequence ID. This is incremented by MySQL every time you receive a new packet that is a part of the same command. So effectively, when you execute a query and you send it to MySQL server, back as a response, you will receive sequence. You can receive multiple packets with incremented sequence ID if your packet is longer than 16 megabytes. So this is how it works. And then there is also a payload. A payload is just a binary string that you can parse based on the length information over here. And then every single packet has an information about how it's implemented. So for instance, there is some generic packets. Something interesting here as well, like if we take a look at this OK packet, it's used a lot in communication. It's a packet that specifies the type of the packet first of all in a header. Yeah, so you see that there is even 2 type descriptors for this packet. Number of active rows, last insert ID. So as you see, MySQL always sends us back this data, and when you usually work with PDO in PHP, right, you have to call a separate method to retrieve this last insert ID. But as I see here, a lot of this data just comes through directly after you execute a query. Then let's take a look. What else do we have here? Session track, system variables, track schema. Oh, this is session state information. This is also interesting. For instance, if you change the database of your current connection, you receive back through the binary protocol, you receive back information that you actually changed the database. So the connection handler can let's say load new schema information or something like this. So it's quite interesting functionality implementation here. Let's go on here. Here's error packet, end of file packet. So it's kind of interesting. Okay. Then we have also error packet. This is something that is sent if you execute a command and it's resulted in error. Then there is some information about character set. This is kind of interesting because when you set up a connection with MySQL, you have to specify in binary your character set ID. So basically it looks like majority of MySQL clients are actually having those character sets being hard-coded. Then we have compression. Compression is not something that I'm going to implement. And then, yeah, we have the most important part is actually connection cycle. So first we receive some handshake request. So we have initial handshake that is sent from a server to client. Client responds back to it. Server checks the compatibilities and then decides what to do further on. So our project is not gonna implement the actual negotiation and so on. It just will provide a basis for working with a socket-based communication with MySQL. So in general, we're gonna give a full freedom to other packages like, let's say, React PHP MySQL package or AM PHP MySQL package to utilize the reader and writer of our protocol layer itself. So let's see where can we go and start off. So first of all, let's take a look what's current implementation looks like. So right now I have very simple implementation here. I have buffer size, I have a current position, current packet, buffer, and binary integer reader. So binary integer reader, it's something that I already extracted as a separate class because it doesn't make sense for me to implement all those integer processing internally in this class. But apart from that, I also noticed that this class has a little bit of clunky implementation because of the buffer size of the current position in the buffer, and the buffer itself being kind of not related to the class purpose itself. Yeah, they are used in a class, but in the end they're just something different. Like, yeah, I can check if it's a full packet. I'm just checking that the length of the buffer versus the current packet length is bigger or smaller, and so like there's a lot of logic here that doesn't belong here. For instance, this read method to read a number of bytes from a packet looks like I just can extract it away because I don't want to deal with this buffer string. I want to make it much more easier. So then, for instance, my read buffer will not be anymore a string read buffer. It will be just a read buffer class, maybe, even without an interface, because it looks like it doesn't have to be. But let's go first to try to implement this kind of functionality. So first of all, my goal today is to implement this buffer variable handling in a standalone unit that I can use later on in this read buffer implementation. So here I'm gonna be looking what I can check with the current implementation of the code base. Yeah, let me see. Yeah, apparently I don't see live chat here. Okay, now I see it. Perfect. So let's see what is a good name for a read buffer. So what is the read buffer implementation here can be? So for instance, we have buffer size, current position, and the buffer itself. So it's like seekable buffer, or how can we call it? Maybe something like discardable buffer, or something we can work on. Instead of using a string here, we just would have a single item. So let's start first of all with a simple test case. Let's call it let's call it maybe buffer. Yeah, I just want to call it buffer, but I also will have write buffer, and write buffer is completely different implementation. So I need to give it a more good name, and read buffer is already taken by that class name. Either I have to rename this one from the read buffer maybe into something different, like read buffer client, or read buffer, or actually maybe it's gonna be a packet reader. I think it's gonna be much better from the name perspective. Definitely, I'm gonna go with the packet reader. So the packet reader sounds like a good name. Let's try to rename it. So how do I rename it in Windows? Probably Control, no, Alt, no. How do I rename it? Let's see. Refactor. Oh, Shift F6, Shift F6, Shift F6. Okay. Why Shift F6 doesn't work? That's strange. So we'll call it read. What I was calling it, packet reader, right? So it will be a packet reader, and it's gonna accept some arbitrary data. And what's cool about PHP Storm, it's actually gonna rename all of the classes for me. So let's see, does it still work? All the tests are green. So here, read packet reader, string packet reader, and here actually I need to rename a test as well. So we will have something like string read buffer test. We can rename it as well. We can just rename it into packet reader test. And here's some kind of an abstraction of the full packet, but also I want to implement this read fragment as well. So this one actually gonna be also renamed. Let's call it as well. Why it doesn't work like this? Why Windows is giving me a hard time? Yeah, without my Mac it's a little bit complicated. So let's try it out like this. So we will do packet fragment reader. So this is gonna be our implementation of the packet fragment reader. So okay, we have a fragment readers that will provide us this message like read fixed integer, read length encoded integer, read fixed string, read length encoded string or null, read null terminated string, read rest of packet string. So those are all stuff that we are just reading. Okay, here it's, I think, is done. Let's run our tests again to make sure that nothing is breaking. So packet reader test is looking good. Here we see that I'm kind of separating the packet reader from the fragment reader because I want to execute the read fragment within a callback. So in case if the data is incomplete, the fragment reader is gonna be throwing an exception that will be catched by a reader itself and return us back into the beginning of the packet. So we don't have to worry about is our packet full or not. We're just gonna try to read it. If it's not readable, we're just gonna schedule it for the next loop iteration. So this is the basic idea of the implementation. Okay, now let's go and implement this functionality. Let's see. Allows to read single byte integer from payload, reports complete buffer when all data provided at once. Okay, so this is all looks good. Probably I will rename it. Yeah, let me see what's wrong with my key binding. Key map. Let's see, maybe I can just use my regular key binding that I use in Mac. So this is a problem. I have this function key here on the keyboard that actually doesn't work very well with this one. Okay, so let's lock the functions in. Let's try it now. Yeah, finally it's all working. So let's switch back my key binding. It was working correct. It's just configuration of my keyboard that was wrong. Okay, so it's gonna be reader, and here we're also gonna rename this one into string. Actually, we're just gonna rename it into reader. Let's call it default packet reader factory. So this is our class that we are testing. Okay. And here we see we have a lot of unimplemented methods, but we'll have more. So let's think about our new class that we're going to create. We're going to create a new class that will be our actually read buffer. So now when we renamed a lot of stuff, now we have actually the real read buffer class. So it's going to be a test for this read buffer. Okay, good. We're gonna extend it from test case, and we're gonna specify first test that first of all, let's think about possible API of it. So what we might want to have inside of this read buffer. From what I see at the moment in the packet reader, like we definitely want to append to it, and we definitely want to read some data as we go, right? So definitely I'll do something like this one. So let's say reads buffer by length. So we want to append some data to it, and we want to read this data back by using some lengths. So first of all, we're gonna create here setup method in which we are gonna create our buffer itself. So this read buffer is going to be our class. Let's create it inside of author-c directory. Yeah, add it to the repository. Then here in read buffer, we're gonna implement some methods like so first we're gonna instantiate it here. Now we just use something like this. It's just an empty read buffer. Then we're gonna have a method called append. So we will add some data into the buffer, like some string, and then we're gonna assert equals, let's say sum, when we ask this read buffer to read a length of 4 bytes long. So we just read this some text here. So let's make this simple test run. So let's see, can I run this test now? Yeah, so it tells me that there is an undefined method called append. So yeah, first we create a method. We don't implement it yet. Let's end after run of the tests. Okay, call the defined method read. Let's create this method read. Length. Return value, blah blah blah. Okay, return empty string. So we fake it till we see the actual failure that is related to our test case. So now we know that the method is running, all the pieces of it running. So we can just fake the implementation. We just return sum, and now our test is green. So we go back to and create another test case. Here we say that reads buffer by moving position forward. Okay, now we are doing something like this. So we read buffer by moving position forward. So what we do here, we just do this read buffer, append some data. So again, TDD is awesome. This is gonna be our buffer data. And here we're first doing something like we're gonna read a length of how long? Of 3 characters. And we expect that after that, we will just receive something like is awesome after we read this read buffer read length of how long, many characters it is? It is 11 characters. Okay, so it's 11 characters long, so it's going to be 11 bytes long as well. Let's see. So failed asserting that 2 strings are equal. That's pretty good. So it means that our test is failing. So we now finally can actually add something to the read buffer. So we will create a string here called private buffer, right? So it will be a string. Here we can just, let's say, use this buffer. Let's just for now set it to the data. So for now we just implement it as simple as possible. And here we're just gonna substring this buffer from length of 0 till this, till the length itself. So let's see which tests are passing. So the first one is now passing because the sum is returned, but second one is not, because after the reading we have actually to move our position. So let's put it like this. Let's extract 0 here as an option. So let's put it like this. We're gonna call it current position. All right. So it's gonna move current position of the buffer. Then we're gonna extract also this one as well, but this one we're gonna extract into variable. So we're gonna use Ctrl-Alt-V, and we'll set it data. Okay. So here we have it, I think, working. Okay, so now this part is done. The only thing that we don't have yet, first of all, we need to set the current position to 0 in general, and buffer probably will have to set some default value as well, so we know it's string, it's never null. Then here we're gonna remove this set to 0, and here we're gonna increment our current position by the length we've read. So let's see. Okay, now our test green. Let me also change the after test delay to 1 second, because I want to receive a fast feedback loop. So let's go and create more tests. Let's go spec reads let's say throws incomplete buffer exception when not enough data to read. Okay, so it's something that we're gonna do. We're just gonna say, let's say we have in read buffer, we're gonna append some data. We'll call it TDD is, and we're gonna try to, let's say, first of all, we're gonna read 3 characters, so TDD is not gonna be there, and then we will try to again this read buffer. We're gonna try to read 11 bytes long, so we expect that there is gonna be some awesome, but it's not there because we didn't add it, so we received only partial packet here. So what we're gonna do, actually, we're just gonna use expect exception, and here we're gonna expect that incomplete buffer exception is thrown, and now our tests fails because the exception is not thrown, so it just silently returns nothing from the buffer. So it's quite interesting. Okay, so also we're actually gonna actually we can just add this function into use statement. So let's add this one. Replace with L. Oh no. No. Control Z. How do I simplify fully qualified name? Okay, so now I just use substring. So why I'm using substring here as a function? Because I want to skip resolution of the substring method within my namespace, so PHP is gonna work faster in extracting the substring function itself. So it's not gonna try to resolve it within my namespace. It's gonna resolve it within a global, and it's just gonna directly use this function from PHP. Okay, so we have string start length. Okay, this is the function. It's okay. The only thing that we are not throwing an exception. So what we have to check if this buffer string len, let's say less than len, we're gonna do what? We're gonna throw new incomplete buffer exception, right? So this is something we are throwing. Okay, our test is green, so let's go further on. So let's go into another test case. So you see we are going step by step. We already created 1, 2, 3 tests. Let's go and create another one. So right now we test that TDD is, and we try to read 11 points. Also, I intentionally didn't implement correct way as I think I should implement. I just implemented it to the way that I can involve my test suites by adding more test cases. So I just try to take a shortcut and implement it as simple as possible. So let me go on and do some new test suite test for this one. So it also should let's say it should also throw incomplete buffer exception. And let's say like this. So this one is the wrong test name because we test that there is something out of boundaries. So throws incomplete buffer exception when buffer is smaller than read size. So this is probably better to explain, and I think we can remove this test case. We can just we don't need to read something, and then we also have to tell that throws incomplete buffer exception when not enough data is left to read. So this is gonna be better test case, I think. Okay, so let's check spelling. When not enough data is left to read. So then we just add this read buffer append, and we append something like TDD is great. And then we're gonna read from it something like, how many characters? 7 characters. Let's read 7 characters here. So we know that TDD is right. So the great one should never be returned to us. So it's 5 character long, and we, let's say, will try to read another 7 characters. So we know there is more than enough total buffer size, but we know that if we read TDD is, there is not enough characters left. There is only 5 of them. So we're gonna ask this read buffer read, and then we ask for another 7 characters. And in this case, we expect that incomplete buffer exception is gonna be thrown again, right? So failed asserting the exception of type is thrown. Okay, because we have an incomplete check, so we check string len buffer. I will need also to deduct this current position as well. Okay, so now it's all just works. So you see, I just modified this single position check here, and everything just became green. So I finished with my functionality implementation. I'm going back to the test, and here I'm gonna go and create another test case. Oh, it's not that test. sorry. So let me go on and let's go into creating another test, and we're gonna call it allows to read all added pieces to buffer. So what we will have here, we will do something like read buffer, we do append, and we do tdd is, and then we're gonna just execute this read, let's say 3 characters, and then we're gonna append something like great with a space here. And now we know that when we read these 3 characters, the buffer should be is space great. So it means 6 plus 2, it's 8 characters long. So we expect that our buffer is returning us something like is great. And it's funny because it's kind of 8 characters long, and it also rhymes with great. So 8 is great. Nice. We can write some rap song. Okay, so now we're gonna read buffer of the length of 8. So 8 is great. And now we see that incomplete buffer exception is thrown, and it's not an expected result because we expect that append will actually add something. So I intentionally left it very simple so I can write a test case that validates a reason for this one to be here. Okay, so now we have actual is great, so there is something off here because because I did not calculate the characters correctly. So we have tdd, so we read tdd, but we expected to have a space here, but we don't need a space there in expectation. I'm not going to change this one, I'm just going to change to make sure that this tdd with space is read. So let's just fix that one. Okay, so now it's actually working good. Let's just remove this line of code to make sure that it's not a fluke test. Okay, let's fix it back. It's green again. Now we can go on and implement other parts of the functionality. So we have append, we have read. What else do we need from a buffer? We need also to check, does it have enough data of particular length to read? So we will create another functionality. We will call it returns true when length is below buffer length itself. When asked bytes are below buffer length. Okay. Then here we will just add some read. We're just gonna append some data. We call it some data. It's gonna be 9 bytes long, and we'll check read buffer is readable. Let's call it like this, and we will ask for 4 bytes. So it should definitely return us what? It should return us true. Okay, call to undefined method, good thing. So we now gonna add this new method. It will take length as an argument. So you see that from method definition you can actually find out that is readable, and then you specify what is readable, this length. So you can see how it's fluently read by buffer, and it's also pretty much related to this read method. So you ask to read particular length, and here you ask if this particular length is readable. Okay, so it tells me that it's null. I want to file it with a type check. So I'm gonna check if it's bool, a return value of blah blah blah, must be a type of boolean non-returned. So let's just fake it. Let's just return back false. So I'm just gonna make sure that my test is failing. Okay, if all returns at false, match is expected true. Good thing. Let's go and return true. Okay, so it works great. Let's go on and implement another test case, and this time we're gonna check that actually let's name this one returns true. It doesn't sound like a good test name. Is readable when asked bytes are below buffer length. Let's add another one that will tell us that is readable when actually is not readable when bytes are longer than buffer length. So here we're gonna return back this read buffer. We're gonna append something like we say sum, and here we're gonna try to check this assert equals. We're gonna check that it's gonna be equals to false when read buffer is readable, check for 5 bytes long, will return us what? Will return us false, but it returns us true because it's hard-coded value. So we're gonna just replace this true with string len of this buffer bigger than length. Let's see if it passes. Okay, it's passes. It's quite good, right? So let's go on and let's implement another test case. So now I'm gonna check that reports is, or say, is not readable when buffer, when asked length is lower than remaining bytes to read. So in this case, we just tell that, okay, we're gonna read through this one. So, okay, we're just gonna tell that it's not readable when asked length is lower than remaining bytes to read. It's not readable when asked length is lower than remaining bytes to read. So, okay, what I'm gonna do here, I'm just gonna read the buff. So we're gonna append some data here, some data, and we're gonna read, let's say 5 bytes out of it, and then we're gonna check that it's not readable anymore when we ask to read is another 5 bytes are readable. So this one should return us false, right? Okay, it fails because it returns us true. So it doesn't take into account right now the current position. So we need just to add it here. So string lang buffer minus this current position. So you see it's already looks quite similar to this one. So we already have just an inversion of this condition. But apart from that, we also need to add another test case here. We just need to add another test case, and we'll call it is readable when exact amount of bytes available. So in this case, we'll have a read buffer. We will append again data in buffer. So it's gonna be how much? It's gonna be in total 14 characters. So we're gonna read from here. We're gonna read 7 bytes, and then we're gonna try to ask if is readable 7 bytes, and it must return us that it is. So we're gonna do assert equals true, that we can still read this 7 bytes, right? It returns us false because our condition doesn't take into account that the length is bigger or equals to the length that we request. So okay, now we have a complete implementation, and here actually the string length also can be replace qualifier with an import. So here we have string length, substring. So those are all native functions of PHP. Then we have here the same thing. So we see here that we have some options for improving our code by just using this inversion of this is readable method of the length. So if it's not readable, then we just throw this incomplete buffer exception, and our read buffer is actually implemented pretty well. So what we can do, our packet reader now can have a new dependency specified here. So we can specify a new dependency. We'll call it read buffer. All right, so this read buffer is going to be our dependency, and we're gonna specify it here as buffer. It's gonna be read buffer, and here we're gonna use a nice tool in PHP Storm called Initialize Fields, and we're gonna get rid of this terrible buffer size, current position, and so on. So we will have something like this. All right, so we will have this one being replaced. So what we have here, now we have failing tests, so we need to fix it. So make sure that everything works. So we'll just replace this read buffer with append of the data like this. Then we're gonna replace this is full packet with this read buffer is readable. So you see how nicer now our implementation of the packet reader become, because we are not anymore checking any current position or anything. We just check that the current read buffer has enough data to read the whole packet itself. Then what we have here, we can also go on and replace it here as well. So here, instead of this read method, actually we can just replace this read method with returning this read buffer, read of this length, and now actually everything looks very good. Okay, nice message from PHP Storm. Expected string but got string. Very nice error reporting, like very convenient. Okay, so let's see. So we have this read. We can actually replace now this one with read buffer, because we better just directly call our dependency here. So we're just gonna call this read buffer. Okay, now we have, I think, everything here. So read buffer, read. Okay, so this one is green, and here as well we're gonna replace this one with read buffer, read of the bytes. So here we have this implementation. Okay, so let's see what we're gonna go and do next. Okay, we have plenty of methods still to implement inside of this packet reader. Let's do a small break and let's come back to the stream in a couple of minutes. So guys and girls, I'm back. Let's continue. So I just opened the chat and Tsvetan asks, okay, what is gonna happen if we have some kind of random characters over there? So if I have some strange characters that are UTF-8, we don't care. Really, we don't care, because this buffer reader, I just use these strings because strings are easier to read in the test, but buffer reader is just gonna read bytes. And if it's multi-byte character, it doesn't matter, because we just gonna read byte by byte. So it's just, there is no reason for us to care about is it UTF or not. I would say like this. So let's see, is stream working? Svetan, can you just write something to the chat to confirm that it's all working? Okay, does it work for you? Okay, good. So Svetan confirms that he understands what I meant by that one. Okay, perfect. Let's go with, let's go further with the test cases. So we're gonna add another test case here, and we're gonna implement something that I need for this one. It's gonna be it's gonna be reading within a snapshot. So I want to make sure that I can start reading within a snapshot, and then I can revert it back if I can't read it completely. Let's see. Just a moment, I need to put my phone on a charge, because otherwise I will miss all of your nice text and messages. Just one moment. So let's go on with the tests. So what I have here is readable when exact amount of bytes available to read. It's done. Now I'm gonna implement something like allow us to read snapshot of the data. Okay, and then what I mean by this one, that until it reaches the point where it cannot read, it will reset the pointer of the current buffer. So I want to implement something like this. So if, let's say, I read a buffer and I have incomplete data over there, so data in buffer, and let's say I would try to read, let's say I first read 4 bytes, then I read another 4 bytes, and then I'll try to read 6 bytes. And here, after I read these 4 bytes, I want to set a check that would make buffer being fixed in time. So I can at any point roll back to the initial position before I started reading all of it together. So what I will put here, I will put here something like drain. So it will be a method that would tell to the buffer that at some point in time, so I read these 4 bytes, and here I cannot longer come back and read this data again. So if I drain it, I cannot read it back. Oh, actually, first I'll ask to read data again if previous session was not read completely. So what I will have here, I will read 4 bytes, then I read another 4 bytes, and then I read, yeah, here it's already how many, 6 characters, so I will try to read 7, and here I will put try catch of this incomplete buffer exception itself. It's just gonna be an empty catch statement. Here I'm gonna make sure that after that one, when I start reading the buffer, let's say another 8 characters from it, what I will receive here, I will receive here information data in and space. So it means I will receive the first part of the buffer that was there before. So basically what I'm testing here, that after I tried to read it once and I received this incomplete buffer exception, the buffer positions being reset to the beginning before I've read this data here. So I can reread the whole packet again. Let's implement then this logic. So here we have this is incomplete buffer exception, and here basically how I can quickly implement it, I just can set current position to 0, and it will just pass a test, because if I cannot read it anymore, I set the current position to 0, I throw an exception, so all the process stops from reading, and we should go one step further. And here I'm gonna implement another one. I'm gonna implement another test in order to make sure that I can also move a cursor that is within a buffer to the position that I already completely read. So I want to also give a possibility for a reader to notify buffer that, okay, the bytes that I read before are not needed anymore. So you just can move an internal pointer of the buffer to the particular place. So let's go on and let's implement this test. And here I will say that allows to move read buffer pointer in front, pointer after read. Okay, and in this case, what I'm gonna test that, let's say I have the read buffer, that I'm appending some data like data in buffer like this, and I'm gonna execute this read buffer read, let's say the length of 5. So I know that the rest of the string is in buffer itself without the space, so it's 9 characters. Here I'm gonna call a method that I'm gonna create. It's gonna be move pointer. So it's just gonna move our internal pointer, or maybe finish read, or maybe we can just say flush. Maybe flush is even better. It's like we're reading and then we're flashing to the point of the data being not needed. So what we have here, we just return here actually void. We are not going to return any kind of result here, and our test actually didn't perform any assertions. So let's where is the test? Here it is. Okay, so we are gonna flash something, and then we're gonna try to read it till the length of, let's say, how many characters we have here, 9. We'll try to read it to the length of 10, so we make sure that we hit this exception. So we're gonna put try catch here, and notice I put an expected exception here. I'm not putting anything except the one that I expect here, because if something happens that is unrelated to my functionality, I want to see it in the test failure. So let's see, we have read buffer, read length of 10, it should fail. And then I'm gonna try to read this buffer again to the length of 9. So now this length of 9 should be equal to this assert equals to date, sorry, not data in buffer, but in buffer. So this is our data that we supposed to receive back. Let's see. Yeah, I want to close this one out. Okay. So we see that it doesn't work because it actually returns us data in B instead of in buffer. So let's implement this one. So now our flash method is gonna use a different variable here. So we will call it red, or actually we can even just do something like private red position string. So if red position, oh, it's actually not a string, it's int, and here it's also gonna be int current position 0, and red position is also gonna be 0. And here we're gonna just set current position to this red position, and here we're just gonna say that this red position is gonna equal to this current position. So now all our tests became green. So what happens here, we just set the pointer of the red position to the current position. So we just internally make sure that it just works like that. Then we're just gonna go on and implement another test case. I think we're gonna implement a test case that, let's say, we will set some string limit. Let me remember what is a string limit in PHP. PHP.NET string max length. Let's see. Full website search. So it should be something like ini settings, but I don't see it here. Max string length, maybe. Let's see. Yeah, but how about the type string itself? Full website search, strings, okay. Okay, so the maximum string can be as large as 2 gigabytes. Can we somehow limit the length of the string itself? I remember there was before an ini option that it was possible to limit the string length. Is it removed on PHP or not? Let's see, string. max string length in PHP. Okay, limit string length. Okay. PHP ini settings. Okay. String and length. Okay, so there is no more limit on the string length itself. So it's a little bit pity. We cannot really set some kind of a limit on that one. So we cannot actually test it out, right? So we have to rely on some different logic. Let's maybe do something like that. So what we actually can do, we can just specify that, let's say we will have some kind of read buffer and we will set some kind of a limit for it, right? So let's set a limit for it of how many biggest number of bytes we had. We had something like data in buffer is 14 characters, this one 14 characters. So the 14 characters is the biggest size, and this one is also 14. This one is 14. So let's put the limit, let's say, of 255. And here we actually will create right away without a delay. We're gonna set here a factory method. Actually, we can even create something like a read buffer factory, but yeah, it doesn't make sense. Okay, let's do it like this. Let's just specify here, yeah, 255. And what I'll do here, I will just create a test that will use a specific test that will compare that creating a read buffer with some limit. Actually, we can just leave it like this. We'll just create new read buffer. My goodness, where is it? New read. Oh, I need to specify a test name. So it's gonna be that clears buffer when read limit is reached. So we're gonna make sure that when we flush a buffer and the number of characters that is read is gonna be flushed from a buffer itself. So what we will do here, we'll just create a limited read buffer, and we'll create new read buffer, and let's actually just specify it in an argument. Let's do it like 20 characters, and we're also gonna create an expected read buffer, new read buffer, and this one, expected read buffer, is gonna contain some data that we expect will be left. Remainder of buffer, and this will be our expectation. So we will expect that this assert equals limited read buffer equals to expected read buffer. So instead of validating some kind of the internals, we just compare two objects that we instantiate with the same arguments, and we just specified some data inside of it. Let's see. So we can now, into the limited buffer, we can append some data like some data to read, and then we will have a remainder of buffer. So this is a part that should be the same in both buffers. So what I'm gonna do, I'm gonna call this length. Okay, so it's 18 characters. Let's add 2 more. Let's say 2. So it's definitely gonna be like enough bytes to verify. So we have 21 character. Okay, let's do it like, put it like this. Some data to read to. Okay, this is 20 characters long exactly. Here we're gonna just execute this limited read buffer, and then we're gonna execute read 20. Right, so we read this 20 characters. Or actually, let's do it even differently. Let's read 10 and let's read another 10, right? And then we're gonna execute this limited read buffer flush. And in this case, both of our buffers must be equal to each other, because at this point, I expect that when we read 20 characters, this limit of 20 should be applied into the buffer itself. Okay, so here I missed a semicolon. Okay, so here we have now clears buffer where read limit is reached. So this one is failing because first of all, I don't have a limit, so we have to construct a new buffer with buffer size. So the buffer size is going to be by default PHP int max. So quite good length, I think. Or how much it is actually is in bytes. Let's just calculate. Byte by 224, 224. Okay, still too big. And 224. No, I think it's too big buffer size. Yeah, it's too much. It's not possible to fit into PHP memory such a long string. So let's just put some buffer size here, maybe something like self, maybe like 1 megabyte. Let's make sure that it's not more than 1 megabyte of data that is ever kept within memory. So we discard anything that is longer than 1 megabyte as soon as we read it. I think it's quite a good rule of thumb. Let's put here some constant definition, so it's gonna be 1024, so it's gonna be 1 kilobyte multiplied by 1024 kilobytes, so it's gonna be 1 megabyte as a buffer size by default. And here we have this one set as an option, and call to private. Oh, I made constructor private. What a bad idea. Okay, so we have our tests starting to fail. Okay, so we have current position and read position. So we see that buffers are not equal. So we have to implement this buffer size limiting. So here we have int 1 megabyte as a maximum size. Okay, so looks good. And we can say that if this read position more than this buffer size, then we do what? We just set this buffer will equal substring this buffer from this read position till the end, and then we also will set the read position to 0. Let's see if it's gonna work. Okay, it's still failing because we didn't set the current position to 0 too. Okay, what's the problem here? The problem is that there is probably one. Actually, nothing is set. Okay, it should be more than or equals. Okay, let's just then put equals, because seems like this one still also passes the test. Okay, then this is clear. And now as well we're gonna implement a test case when clears buffer when limit is reached a long time ago. So let's say we have 2020, but let's say we've read a very long string, to read some data to read to very long string to read. So it's gonna be how many characters? It's like 45 characters. So we read and we do a flash here. Then we also will do another read of 20 characters. So in total it should be how many? 10, 20, but what we expect for is 45. So we still need another 15. So we will do limit read buffer, read 15 characters long, and then we will flash a buffer again. So now we have something like first failed asserting that two objects are equal, and this is good that it's failed asserting, because it means that, yeah, our buffer is not what we expect. So here we are. The buffer seems like already almost implemented. The only things that we need to fix here, we need to fix that the read position is more than equal to the buffer size. So what happens here, again, let's walk through. So first of all, when we flash, we just set the read position to the current position in the buffer. In case if the read position is higher than the buffer size, so in our case it's by default it's 1 megabyte, but in case if we set it manually in a constructor to arbitrary value, we can really test that in case if the buffer size is reached, we actually slice the buffer till the read position, and then we set the read position to 0 and current position to 0 as well. So we make sure that when we flash, we have a very good data to start. So we never store strings bigger than 1 megabyte in memory. So we make sure that our parser is memory efficient and we don't grow our strings to 2 gigabytes. That's what's possible in PHP by default, apparently. Okay, so seems like buffer looks good. Let's see what we can do next. So the next step is gonna be implementing that functionality with the packet reader here. So we just gonna create new tests for a packet reader that's gonna utilize our new buffer reader in new ways. So first of all, we're gonna add another test. So we have here a packet, and let's say we are now gonna have actually 2 packets. So we have one packet of 1 byte size and another packet of 1 byte size. So in ideal situation, these packets must be detected as 2 separate packets by our reader. So allows to read single byte allows to read multiple packets. So it means that okay, what we can do, we can actually increase this one by 1. I think it's gonna be 2. Okay, I'm bad at hexadecimal parsing, so let's do like this. Hex dec F2. Let's see what's okay. HO, it's 242. Yeah, so I think I'm good enough with this one. So I expect that the data will be 241 and 242. So we just increased it by 1. So here we have read fixed integer of the bytes 1, and we need to read it actually 2 times. So I'll call it read 1 byte. So here we're gonna read fragment 2 times. So we expect that 2 times it's gonna return us different data, because it is supposed to just move the packets after each other. And here is actually as well, we need to invoke on our reader actually in the next packet function. So this one should work. Okay, so allows to read multiple packets fails because the data is not what we expect, because we received as the next result we received actually the length of the buffer. So okay, we read this packet. Now what we do, so we go to the next one. This next packet is probably not implemented yet. Yes, it's not implemented yet. Because it expects that I'm gonna pass the current packet information in there. So okay, after we read fragment, first of all, what we do here, we are probably gonna continue with this one. Oh yeah, I have here as well a small issue because it's readable. It's not taking into account how much data from the current packet is actually has been read. Right, so that is probably what Flash should return us, right? Flash should return us number of bytes that have been moved. So let's add another test case. Yeah, this is something that I completely missed. Flash returns a number of read bytes. So append some data, and let's say we will execute read buffer read, let's say 4, and then we execute this read buffer flash, and I will assert equals that this flash will return me what number? 4, or even better to do something like 2, and then we'll just assert that it's equals to 6. So okay, fail deciding that 2 arrays are equals. Okay, it's okay, but the other one, what is interesting, is the read buffer. So flash returns number of read bytes. Okay, here we just need to return back an int, and int is gonna be bytes read. So it's gonna be this read position minus, actually current position minus read position probably. So this is gonna be probably a number of bytes that is read, and then we're just gonna return back this bytes read. Is it gonna work? For this one, no, but for the other test case, okay, let's return 0 to see it's failing. Okay, why it's not after expanding it? Expand all test results. Okay, flash returns. Okay, so now we can just return this bytes read, and looks like the test is green. The test is green, and it's very cool. So now the flash returns us number of bytes read. Read returns us the string, and now we're gonna go back and also add another just small edge case. Flash returns 0 when no bytes read. So this read buffer, append some data, and as soon as we call this flash, read buffer flash, we assert that it equals 0 because there is nothing has been read. right? Okay, so it's green, so I have to actually make it -1 just to make sure it fails. Okay, if it fails, I just can implement it. This is sometimes happens that you implement a test but it's actually green, so you just want to make sure that there's nothing wrong with your test, so you just change the output value to see that your test is running and it's working well. So now the test is actually testing this H case just in case. Now we go on into the next stage, right? So we need to read multiple packets. So why did I add that functionality? We will come back to that one later. But first of all, we just gonna navigate to the next packet. So we read a fragment, we go to the next packet. So this one I think we can implement easily by just calling this init packet, right? Yes, perfect. So here we have an init packet method being called. And here we actually can remove this redundant read function. So okay, we go to the next packet. Here we're gonna implement now a couple of more checks for isFull packet, because I know that my implementation is broken, because as anything in TDD, unless you write a test for it, there is no line created for special H cases, so you just make sure that every single line is covered with tests by evolving your test suite together with functionality you write. So here you create another one, we call it reports complete packet available even after fragment is read. So what we're gonna do here, we're gonna use the same packet we had before, that is 1 byte long. Actually, let's do it 2 bytes long, so we will have at least 1 more byte available. So let's do it F2, so it's gonna be 2 bytes. We read 1 byte from the packet, but the packet is not yet complete. So reports complete packet available even after fragment is read. Okay. So what we're gonna have here, we're gonna read a fragment. This reader read fragment. It's gonna be just read like this. We don't need actually to retain any data. We know this part already works from previous test cases. We know that it reads 1 byte. Then what we're gonna do, we're gonna check that isFull packet is still gonna return us true. So assert it equals true. isFull packet after reading 1 byte. So we see it returns us false. It returns us false because here in a full packet implementation, I don't reduce the current packet length. What actually we can do as well, I think I can just improve this functionality a bit, as we don't have anymore, we actually don't have anything related to the read buffer in this class, so we can actually create a meaningful name for our packet, current packet information. So we can call it current packet length. So we can say it's 0 by default, and we can set that this current packet sequence. So we have actually let's not call it 0 and length, because we want to check for those values later on. So we're gonna set here int as length of this one, and sequence also gonna be int. Here we're gonna specify when we actually read the current packet, we're gonna specify current packet's length is gonna be read fixed. Of 3 bytes, and here we're also gonna specify that this current packet sequence is gonna be equal to this binary integer reader read fixed, and then it's gonna be what it's gonna be this read buffer read 1, so it's 1 byte integer. Also we're gonna read we're gonna pass 1 to it, so this is gonna be our packet initialization. And where else I call it, I also call it here, and here we're just gonna test if this current packet length equals to null, so it means it's not initialized. We're just gonna call init packet. Okay, cool. It's now adds a lot of errors because our current packet's length is I checked over there. Okay, so we have current packet length set to the specific amount. So when we read the fragment, when I actually completed the reading fragment of the fragment, we need to flash our buffer. So here is actually where we're gonna decrease the size of our current packet length. So basically, as soon as we finish reading the current packet, we reduce the packet length. All right. So this is, I think, is a good thing, right? So we are done with an implementation. Okay, so here we have this one done. Now let's go into the packet reader. Reports complete packet available even after fragment is read. Okay, this is good. Now let's add another one. Let's add a test for read fragment. As you saw, the read fragment by the interface, it must return us true if the packet is read, but you saw we have hard-coded false over there. So we need to test that when reports fragment is read, so we have again our bytes. Let's make it again 1 byte, and let's just do something like 0, 1, so it's gonna be 1. And I'm gonna execute reader read fragment function this fragment read fragment reader fragment reader. Okay, let's simplify it to a single name. Here we have reader, and we're just gonna read fixed integer again of 1 byte, and here we're gonna return back Yeah, so here we're gonna assert that this assert equals to true. So it returns true when 1 byte is available for it. Okay, so this should be on this line. Okay, now we have an assertion and it tells us that it returns false. Okay, so let's just return true. Okay, now it's working. So let's go on and let's create another test case. Now we're gonna check that if the fragment is not read, it returns us false. So how can we ensure that the fragment is not read? Reports fragment is not read. Okay, so here we have reports fragment is not read, and here we gonna so here we're gonna check also, we're gonna append this info. We're gonna tell that our packet is 2 bytes long, so this indicates that it's 2 bytes long. Then here we have the rest of the size specified here, and here we have only 1 byte specified. So if we try to read a second byte here, it should return us an exception. So in this case, our read fragment needs to catch an exception and it needs to return false. Okay, it's not executing my test case, so I forgot to annotate it, so let's do it. Test. Okay, now it fails because there's an exception form that I didn't catch. So let's catch this one. Let's try and use this reader inside, and let's catch incomplete buffer exception only, nothing else, because if it fails for some other reason, we want to propagate it all the way through. So if it fails for no reason, it means our application fails, so it should just fail completely. Let's go on and let's go read fragment. Let's go back to this one. Okay, so finally we're in place, and if we catch it, what we do here, we return false. So it means that, yeah, it works. So now it's all green. Let's go on and implement another test case. Let's go and create a test case when, let's say, we have a buffer and we try to read something that is longer than a packet. It's probably invalid buffer that we received from MySQL, because in case if some packet is supposed to be read, oh, actually it's not. It's not, because then we just need to move to another packet, right? So if we have a packet in MySQL with payload that is separated by 16 megabytes, let's see what MySQL documentation tells us about it. So if we go here, I remember there was something about the protocol packets that are bigger than 16 megabytes. So let's see what's happening there. So let's say we are sending a packet of 16 megabytes. Split the data into packets of size of 16 megabytes, prepends to each chunk a packet header. Okay, data between client and service exchange, blah blah blah. Then we have if larger than or equal to, the length is set to FFF, and additional packets are sent with the rest of the payload until the payload of packet is less than this number of bytes. So sending a payload of this size, so this is our 16 megabytes, looks like this. Okay, it's not clear from this one how to actually work with this one, so let's see. This is very nice note. Some packets have different lengths. Okay, let's see. So file list. I think it's in libMySQL. Yeah. Client settings. Actually, client, then MySQL. Okay, nothing here. Let's take a look again at this client server protocol, protocol basics, MySQL packets, protocol packet. Where can I? There was somewhere reference to the actual line in C code that is possible to take a look at. Let's see, overview. Okay, server status. Oh, here's all the one. Okay, so MySQL com. This is probably the one that I need. Common definition between MySQL server. Okay, not much. Okay. Okay, it's crazy. Where is this one? Enable disable multi-results. Okay, there is nothing I can actually look up. Let's see if I can find it actually in source codes. It's always fun. MySQL, I think there's, by the way, we're gonna jump into the right package, MySQL server. So let's go on. Yeah, so here we're gonna have some client implementation, and then we have client yeah, read line, it's not something that I probably have to do. Let's see. MySQL CC, it's probably the one that I need to look at. Probably init connection options. MySQL init, okay. Init connection options. Then we have this one. Okay, what does it look like? Okay, so MySQL options, bind, compress. Yeah, it's gonna be a lot to take a look at. Okay, it's SQL real connect, real query for lazy. Nice. Let's see. It's nice that they call this functions like MySQL store results for lazy. Very convenient, very nice for MySQL developers. Okay, so I got a question from Tsvetan. Tsvetan asks, are you planning to use this on production projects? If yes, then what is the advantage you will gain? So first of all, why I'm building this project is because by default in PHP there is no way to execute asynchronous queries to MySQL. So when you do a MySQL query, as soon as you send something to a MySQL server, your PHP process will just block until you receive back the result from MySQL. So you cannot do anything else. And when you build a synchronous HTTP server, it's important to not block your HTTP processes, because you just might receive part of the data from MySQL. You can do something, and then you can switch and go parse HTTP requests and process client connections, return some data, prepare other queries, and so on. So instead of just blocking and waiting, you also process other customers. So the advantages are huge. I already built a proof of concept with another library that implements very basic MySQL protocol communication. It's called, let me show it to you. It's called Friends of React PHP MySQL. So this library is implementing a very simple MySQL protocol where you can just execute a queries and then expect that there is some result returned back. However, the problem with this library is that it doesn't allow me to execute prepared statements, as well as it doesn't allow me to execute multi-query results. So I'm working right now on a customer project that requires me to run it in to run actually a single query that might return multiple result sets, and this library doesn't allow it. So I have to write my own, unfortunately. And I already was talking with the maintainer of this library, and he is more than happy that this protocol will be implemented, because he will be able to replace the parts in his implementation that parse MySQL protocol. Because if you take a look at the code that's working here in parser, there is a little bit of a mess, because when it parses data, it appends something to the buffer. It's does use labels, as you see, like there's a packet, then it checks for state, then it checks different if statements, then there is a huge list of the stuff here, and then in the end it goes to the buffer trim, and then it executes a goto statement, and a goto statement in this kind of a thing looks a little bit strange. So the second one that Svetan asking about is extracting fixtures. So definitely I'm gonna still write integration tests on a real MySQL connection to validate that I can connect through this parser and serializer. I can connect to the real MySQL server, but it's gonna be part of the integration test, not the test that I'm writing just for parsing binary data. So at the moment, I'm just making sure that I can process binary data one by one. So I can read particular data that exists over there. So this is the basic idea here. This one looks very nice, but unfortunately, right, I have to do a lot of different implementation that is not available here. So for instance, here it's basically directly reads the binary data, but after implementation of this protocol parser, it will be more kind of a message-based notification. So there will be kind of a parser in which you're gonna expect that there's gonna be some response back from MySQL server, and you don't need to do any kind of reading like this. You will just receive back the full information, like either it's handshake packet, either it's authentication packet, is it error packet, is it okay packet, is it a query result start, is it query result row, is it query result header, is it query result end, or is it just a final result of the command execution? Because here in MySQL there are so many different things here that you actually receive that you even don't have in standard MySQL query execution. So for instance, you have okay packet, and here you have the whole information about the status, like you have the number of affected rows, number of this last insert ID, you receive status flags, and you receive all those additional information back. So here is something that we can see. For example, MySQL packets, I think we have connection lifecycle, yeah, command phase. So when, let's say, we send something like query. As a result, we receive com query response, and com query response can be something like length encoded integer, and then we can have an error, or we can have this kind of result set where there is a field count, there is a field, there is end of field, row, and then there is a lot of rows, and there is final end of field. And then here is again another variation where you have the result set for more data. Yeah, so it's quite interesting. So you have more data, and then you have to parse it, and then you have to go again. So yeah, there's a lot of things. A row with data for each column. Okay, null is set as so length encoded string. This is something that MySQL sends as payloads for this kind of data. Okay, I think it's gonna be the end for today's stream. I'm a little bit tired already of doing it, so I need to have some rest, and the next time we're gonna continue with MySQL protocol implementation. Probably I'm gonna do also some other progress. So thank you guys and girls for listening to this one, or whoever you identify as. So have a nice Tuesday evening, and talk to you next time.